Hi, this is Krishna Mathur. I'll be solving the first question. So the question states that there is 20,000 cubic feet of air present in a room. 600 cubic feet of fresh air per minute enters it, and 600 cubic feet of mixture of air is exhausted per minute. So now let us assume y of t as the amount of fresh air present in the room. Now, so we'll have to now find the differential equation which will provide us with the amount of fresh air present at any time t. So the rate of uh, I mean the rate of change of the amount of fresh air is dy by dt. So dy by dt is equal to the total amount of fresh air that comes in per minute, which is 600 cubic feet, subtracted by the total amount of fresh air that goes out. So the amount of mixture of air that goes out is 600 cubic feet. So now, in order to find the amount of fresh air that is exhausted, we have to multiply the amount of fresh air that is present in the room at any time, which is y, into the fraction of amount that is being exhausted, which is 600 by 20,000, which implies y dash equals to 600 minus this is how much, 0.03y, which implies y dash plus 0.03y equals to 600. Now this is our differential equation which we'll have to solve in order to find the relation between the amount of fresh air present at any time, I mean time and amount of fresh air that's present. So as we can see, this is in the form, this equation y dash plus 0.03y equals to 600 is in the form of y dash plus p of x into y is equals to q of x. So any homogeneous differential equation of this form can be solved by finding the integrating factor. So the integrating factor here is e power integral p of x dx, which is equals to e power, now p of x is this coefficient of y term, 0.03 dx, which is e power 0.03 x. Yeah, so these are what is saying integrating factor. Now the next step is multiplying the integrating factor on both sides of this equation. So dy by dx into e power 0.03x multiplying the whole equation with dx. Now by applying integral to the whole equation and simplifying it, we will get y, this will become in the form of y into integrating factor, which is 0.03 x, is equals to integral q of x into integrating factor dx plus c, which is our arbitrary constant that comes along with the integration, indefinite integration. Yeah. So now in order to solve this, let 0.03x equal to u, 0.03 dx equals to du, which implies dx equals to 100/3 du. I forgot the integrating constant, so let us take this as c1, as we have already used c. Now we get, which implies y into e power 0.03 x is equals to 20,000 into e power 0.03 x plus c. This c1 which we calculated here, we'll just add it up with c, because both are anyway arbitrary constant, so it doesn't matter what we actually represent, which alphabet which we represent it with. And now dividing this with 0.03x, we get y is equals to 20,000 plus c divided by 0.03x, so c multiplied with e power minus 0.03x. I'm sorry, this is 0.03. Yeah, so 0.03x. Now so x is just a variable because we want to find the time, so let's just consider x as t, which it'll just be convenient for us while we are calculating further on. So which implies y is equals to 20 plus c into e power minus 0.03 into t, and we know the initial condition at t is equals to 0, y equals to 0, which is basically y of 0 equals to 0. Yeah, so 0 equals to 2123 plus c into e power 0.03 into 0, which is e power minus 0, which is 1, which implies our arbitrary constant c is equals to minus 20,000. So now we get our equation as y is equals to 20,000 minus 20,000 into e power minus 0.03t. So this is our equation, the relation which will give us the amount of fresh air present at any time t. Now we have to calculate the at time the time t not at which, when the room is filled with 90% of fresh air, which implies, which gives us that what do you say, yeah, so the amount of fresh air inside the room should be there has, I'm sorry, excuse me, 90% of the amount of air that is present in the room has to be fresh, which implies 90% of total amount of fresh air, air that is present. So 18,000 cubic feet of air inside the room has to be fresh air. Cubic feet, which implies why this will be our y here from in this equation. So 18,000 is equals to 20,000 minus 20,000 into e power minus 0.03 t. Now on simplification, how much? 9 by 10, and then 1 and e power minus 0.03 t. Yes, perfect. Which implies e power minus 0.03 t is equals to 1 by 10. Yes. Which implies minus 0.03 t is equals to ln 0.1, because e will be shifted to the, transposed to the RHS. We will get t approximately, I guess, let me just calculate. Yeah, 76.9. So let's make 77 minutes. Thank you.